Muller's method is a generalization of the second method. Instead of using two assumptions and joining them on a second line, we use Muller's method in which it starts with three approximations to the roots and join them with a parabola. After that, we use the quadratic formula to find the roots for the next approximation. Here are the given formulas for Muller's method, and here is the continuation. The step-by-step calculation for Muller's method is solve for the function of x sub 0, x sub 1, and x sub 2, and get or solve the following formulas, and then solve for a, b, and c, find the discriminant, apply the formula for the next root, and get the approximation error. We will talk about how a Muller's method is used. Now we are given a function of x cubed minus 13x minus 12 and have initial values of our x sub 0, x sub 1, and x sub 2 is equal to 4.5, 5.5, and 5. Now, first thing we will do is get the functions of the following guesses. F is equals to 4.5 is equals to 20.625, and our f 5.5, function of 5.5 is equals to 82.875. Now our function of 5 is equals to 48. Now in these functions of x sub 0, x sub 1, and x sub 2, we can use the following formulas for the Muller's method, in which h sub 0 is equals to 5.5 minus 4.5 is equals to 1. And our h sub 1 is equals to 5 minus 5.5 is equals to negative 0.5. We can use these following functions on our delta 0 and delta 1. Delta 0 is equals to 82.875 minus 20.625 over our h sub 0, which is 5.5 minus 4.5, which we will get the answer 62.25. Now we will calculate our delta 1. Our delta 1 is equals to 48 minus 82.875 over 5 minus 5.5 is equals to 69.75. Now we can get our A, which is A is equals to 69.75 minus 62.25 over negative 0.5 plus 1, which is equal to 31.54461. Now we will get our B, which is B is equals to 15 times negative 0.5 plus 69.75 is equals to 62.25. And our C is just equals to our function of x sub 3, which is 48. Now we can use it in determining our root by using the discriminant, which is b squared minus 4ac, square root of b squared minus 4ac. Now we substitute the values of b squared minus 4ac. B squared is equal to 62.25 minus 4 multiplied by 15 times 48. We can get the we will get the answer as 31.54461. Now we will pause. Now we will use the formula for getting our next x, which is x sub 3 is equals to 5 plus negative 2 multiplied by 48 over 62.25 plus 31.54451, which is the maximum value of the our determinant, is equals to 3.976487. Pose. Now we can get now our approximate error, which is approximate error is equals to the absolute value of negative 1.023513 over 3.976487 times 100 is equals to 25.74%. Now, our x3, we will substitute our x3 to the our initial values. Now we will get our new set of initial values, which is x1 is equals to 5.5, our x2 is equals to 5, and our new initial x is equals to 3.976487.